Hey robot makers, hope you're having a good day so far. So do you want to learn how to make your own search engine using Python and something called FastAPI? Then this is the show for you. So let's dive straight in. My name's Kevin, come with me as we build robots, bring them to life with code and have a whole load of fun along the way. This is kind of a robot adjacent show today, I would say. Okay, let's get over to our slides. So yes, this is all about how we can build our own search engine. So a bit random, but it's very, very useful and surprisingly easy to do. And really this is kind of highlighting FastAPI, which is a piece of software library for Python, which makes building web interfaces very, very simple. So FastAPI is a modern, fast, high performance, and they really mean that, web framework for building APIs, application programming interfaces, using Python, and it works from Python 3.8 upwards. So some of the key features are it is very, very fast. So very high performance, on par with Node.js or Google Go, which is quite impressive. It's fast to code as well. This is the reason you would choose this rather than just rolling your own. So the increase the speed of development features from about 200 to 300%. So it's like ridiculously fast. One of the reasons I chose it for two of these projects I'm going to show you today. It's really easy and intuitive, so if you know Python, this will be a piece of cake. It's been designed to be very easy to learn and pick up, less time than reading any kind of documentation. And it's really short as well. There's not a lot of code to actually learn. It's very, very simple. Lots of features and parameters that all work together very nicely. And it's very robust. This is production ready code. Has automatic interactive documentation. I'm actually going to add that to my list of things to show you actually, because that's pretty cool. And it's standards based as well, so it's based on and fully compatible with all the open standards such as OpenAPI, previously known as Swagger, and the JSON schema. Okay, I'm just going to mute that for a second. So what are we going to use this FastAPI for? So I'm going to do some upgrades in the next coming weeks and months on kevsrobots.com. Kevsrobots.com is my website where I host all my projects, all the robots, all the builds, instructions, video links, everything. But it's statically generated. So I use Jekyll, which is a piece of software that's based on Ruby, I believe. And that takes a load of markdown files, which are very plain text files. I will show you those as well. And I'm going to make a note of that. And it then converts them into full HTML pages with beautiful CSS using Bootstrap for some of the nice CSS to make it look very pretty. So like I said, it's statically generated. That means there isn't very much interactivity on there. So I want to bring more interactivity to kevsrobots.com, and I'm going to do that by building out some APIs with FastAPI. I'm going to include things like user accounts, so you'll be able to sign in and have your own favorites and so on. You'll be able to like and comment on posts, on projects, videos, everything on the site. And you'll also, if you're a member, be able to get some extra benefits as well. Things like the courses, you'll be able to save your progress. So that's the kind of things I want to build in, rather than just being completely statically generated. I'm also hoping to bring user-generated content as well, so you'll be able to share your own projects on KevsRobots and then share them to the world. It'll make it very easy to do that. So previously I built two APIs using FastAPI, and that's what I'm going to showcase today. So one of them is Robot Facts. So when you go to kevsrobots.com and scroll down a little bit, you'll see that there's a random facts thing on the page. That's actually grabbed from just behind me there, those 4 little Raspberry Pis. They're running kevsrobots.com live, and they will grab the fact of the day, or actually every time you refresh the page it will give you a new fact. That runs on FastAPI and some Python code in the background. And also on kevsrobots.com there is a search facility. That search facility is built using FastAPI and some other things as well, which we'll go through in detail today, just to show you how all that works. So how do we build this? So this is the challenge. We're going to have a website, kevsrobots.com, statically generated, like I said, which means there's no interaction, but we can build interaction by using something called jQuery. This is like a JavaScript query language that you can plug into your website, and it can query things like get weather information, or it can basically query any API, and we can build an API for it to query. So the APIs that we want to build is like a login, register, manage account, like posts, that kind of thing. and that will be using FastAPI. And then we'll have a database in the background that will store all those user accounts, the comments, the likes, and so on securely. So that'll also be running on those Raspberry Pis behind me. Not chosen which database I'm going to use yet. Probably going to be PostgreSQL because I'm familiar with that one and it's pretty robust. So the random facts, I'll show you how this one works. This is a nice simple one because it's kind of a one-way. We just grab data and we can then display it. So we get fresh facts every time we refresh the page. So how do we do this? So we're going to gather 100 and odd random facts about robotics into a table. We're going to load those facts into a database. We're going to use SQLite because it's a nice simple database and it's built into Python, so there's no extra drivers or anything to install. And then we're going to write a Python program that will provide the API, and it'll basically grab the latest fact, a random fact from that database, and then provide it to the API. I actually use Cloudflare to do a lot of the routing to my clusters. That little cluster behind me just there, you can see them flashing away. When you go to kezrobots.com, you're routed through my home router through to this via Cloudflare. And Cloudflare can add an extra layer protection for things like denial of service attacks. It also gives it the certificate. You get the little padlock on the on your browser as well to show that it's secure. So we're going to provide some jQuery onto the kezrobots.com website, and let's make sure I've got that included as well. Let's include that to my list of things I want to show you. And that can basically just provide access to the API for the web page, grab the latest facts and then display it, and it essentially rewrites the web page. So it's quite cool that it can do that through your browser. It's a client-side piece of software, and you can try this out right now. If you head over to facts.kezrobots.com/random-fact, you'll get a random fact. It isn't pretty, it's just the pure JSON, but we'll have a look at that in the demo in a second. So this is the random facts. I think I've got over 100 facts in the database so far. Here's a couple of examples of the things that are in there. So the word robot is a Czech word, robota, meaning forced labour. The first digital and programmable robot was built by George Devil in 1954. And Asimo, which was developed by Honda, was one of the world's first advanced humanoid robots. So you can see there's a couple of other random facts there too. This just gives the website a bit of freshness when you visit it. Now, one of the cool pieces of software I wanted to highlight today, and I'll showcase this in a minute, is the DB browser for SQLite. I think they have other versions as well, but it's completely free. It works on Mac, Windows, Linux, FreeBSD, all the platforms. And you don't need to have any SQL knowledge whatsoever to use it. SQL is the structured query language, and it's a way that you can interrogate databases to get information out of them, put them in, delete them, maintain them. But you can also just browse the data just like a spreadsheet using this really cool piece of software. So if you haven't got that, you can head over to https://sqlitebrowser.org and download yourself a copy. Like I said, completely free. It's maintained. It's a really nice piece of software, and I use it when I'm working with SQLite 3 databases just to see what's in there, maybe delete some records if I'm developing something and I want to clear them out. So if you like this video and you want me to make more videos like this one, please make sure you give this video a like. Drop me a comment, let me know if you built yourself a search engine, or if you've got any other cool projects in Python that you're working on. I'm really keen to know what you're working on. And if you haven't already subscribed to the channel, please subscribe. It means an awful lot to me and it helps the channel grow as well. I do go live every single Sunday at 7 o'clock GMT, or British Summertime, whichever one we're currently in. I think we're a couple of days away from it being British Summertime, so it'll be jumped back to the in alignment with the US Daylight Savings, I think, next week. Cool. So let's have a look at some code, shall we? So what I'm going to do, I'm just going to flick over to Visual Studio Code, and I'm just going to get my browser thing ready here. Let me just jump to this. Okay, and then I will share my screen so you can see what I can see. Right, so let me just jump over here. Okay, so of course it's got a bit of a bug in this. Whenever I jump over to the thing I want to show you, it seems to go to the wrong thing. So I'm actually on Visual Studio Code. There we go, that'll do for now. And let me just get my... Basically, I want to show you in the terminal what we're doing, so let's just clear that out. And let's go to let's go to the search app. Not the search app, the random facts app, which I think is actually a different window. Just bear with me a second. There we go. So let's just zoom into that. Let's just hide that. Let's just get rid of those. And right, here we are. So I've got a number of different files in this folder here. So you can see I've got like a README file. I have a Python cache file. We'll discuss what that is in a minute. There's a Docker compose file, a Docker file, a facts database, some random facts Python program, the raw facts, which is a markdown table, and we have a requirements.txt and a virtual environment. So virtual environments are really important. I'm just going to jump over here and see if it'll let me play nicely with this. So virtual environments are really important. Just make sure that goes down there. So there we go. That's better. So yes, virtual environments are really important for separating out your code dependencies from other projects that you're working on. So one of the first things I do whenever I'm starting a new project is I'll come down to the terminal, I'll do Python 3-m venv venv, and that will create me a virtual environment where it will store a copy of Python, whichever the latest version is that you've got on your machine, and it will also put any dependencies in there that you install using pip. And it means that you can keep everything together. And in fact, that requirements.txt, if we just do catalog what's in there, you can see there's a whole bunch of dependencies that we need to make this particular facts thing work. And the way that we can do that, when we install something like, if I just do pip install, I don't know, upgrade pip, always seems to need upgrading whenever you install something. That puts some dependencies in your virtual environment. So if you do pip freeze, you can actually see all the libraries that are currently installed in that virtual environment. And if you do pip freeze and then pipe that out to a file like requirements.txt, that essentially lists all those in a file, and then later on you can say pip install -r for requirements and then requirements.txt, and it'll basically go through that file and install all the dependencies. So if you clone this repository and download it, you can simply create yourself a virtual environment, use pip install -r requirements.txt, and you'll get all the installed dependencies for this particular project. So that's the first thing that I usually do when I'm working on a project and I'm storing the code in source code control like GitHub. Cool. So the next thing I wanted to show you is I've actually got this running in a Docker container. So if we do cat Docker file, Docker file. So this Docker file will actually build the container to run this app. So you can see in here we've got from Python 3.9 Slim, so it's like a small version, doesn't take up much space. It's going to install that as a base. We're then going to we're going to set the working directory to /app. We're then going to copy the requirements.txt to app. We're going to do pip install no cache directory -r requirements.txt. That basically just means don't use any locally cached version of this, and make sure you download a fresh copy. Then we copy everything that's in the current working directory into this /app. This is in the container itself. We're going to expose port 8000 to the outside world, and then we're going to run this command, which is uvcorn random facts and then app, which is the name of the app we actually want to run within that random facts.python program. And then --host means we want the host IP address to be 0000, and then the port to be 8000, which we expose to the outside world. So that will actually build the container. And the way that we can do that, we can do docker build and then dot, and that would essentially go and build that container like so. You can see that's going to grab everything it needs and so on. I'm actually going to cancel that because we don't need to do that right now. And then there's a Docker compose file. So Docker compose means that we can automate the building of that container and then the actual running of that container and deploy it. So if we do docker-compose and then up-d, that will actually it'll build the container and then actually run it locally on whichever machine you've got. So I've got this running on, I think, one of the Raspberry Pis behind me. So let's have a look inside that Docker compose file, because that essentially gives us all the instructions on how to run this. So version 3.8 is the version of Docker compose that we're using, and the service that it's going to build is called web. It's going to build using the Docker file that we've got there, and it's going to expose port 8000 and actually expose it on port at 8003, because I think I've got something running on 8000 already, and it will restart this. If it crashes, if there's any kind of problems with a Python program, it'll keep restarting it unless we tell it to stop doing that. And then we'd simply just use docker compose up-d to bring that service up, and it'll keep running forever then. So that's running, like I said, on one of the Raspberry Pis behind me. I think it's the fourth one. So that's the Docker file. So let's have a look now at the random facts. So let's go to random facts. Random facts. Well, I think it's just called raw facts, actually, raw facts. The MD, and essentially we've got a table there, and you can see there we've got about 100 random facts, and I've generated these. I think I've grabbed them from various different places off the web. So there's a fact number, and then there's the actual fact itself. So I'll put these in markdown format. That's actually how you do a markdown table. You do like a pipe, some column data, another pipe to separate the columns out, and so on. So that is our raw data. We're going to take that and we're going to build a database from that. So there's a couple of different ways that we can do that. I've basically just written a very small function within my main program to take that markdown file and then build a database from that. So let me just show you. I'm actually going to go into here now. Let me just bring this window down a little bit so we can see what's going on. Okay, so this is the main program that provides the API, and we'll do all the building of the database and so on, and we'll have a look at that database using the DB browser in a second as well. So we're bringing in FastAPI, so from FastAPI import FastAPI. We had to do pip install FastAPI first of all to bring that in. We're bringing in the random module. This is so that we can randomly pick a fact. So that helps us with that. And then we've got this, not sure what the CORS stands for, but it's essentially like it stops, it's designed to stop web pages from accessing data outside of their domain, because that can be like an attack. So you have to have this middleware to prevent that from causing a problem. So that's essentially what this CORS stands for. I'm sure somebody can Google that and tell me in the comments what that actually stands for. It's something like cross-origin restriction, something like that. Anyway, next we have SQLite 3. This is our database backend. This is part of the standard Python. It's actually used on a lot of iPhone software, because that's also built into iOS, as well as the way you can store data locally and access it using SQL, structured query language. I've also got their import OS, but the fact it's grayed out there, it's actually not being used, so I could probably comment that out. Okay, so the first thing we then need to do is we need to create an object that will be our FastAPI little class. It'll take that and make it real. We can then add this CORS middleware, and we can basically just say the origins, the credentials, the methods, and so on. It's just everything. We're just letting everything through. And then we have the get the random facts function. So this is the main function. So it's going to create a connection, a cursor to the database. We're going to pass in the database. It's called facts.db. If that doesn't exist, then SQLite will actually create a blank database for you at this point. So the cursor there is going to be connection.cursor. That's essentially where in the database it's currently pointing to. And then we can execute select count star from facts. This is going to tell us how many facts that we have, and we can store that in count. So once we've executed it, the results are sat there, and we can then use the cursor.fetch one, fetch all, whatever, and bring that into the variable. So that count variable now has the number of facts in our database. We're then going to say random ID, so rand int 1 to the count. So pick a number between 1 and the maximum number of facts that we have in our database. That'll be stored in random ID. And then we can say cursor.execute select facts from facts. That's our table, where the ID equals question mark, and that's basically a placeholder in SQL to say, and then use the random ID in place of that. So only select the facts in our facts database where the ID equals that random number. So 1 to 100, it's going to pick a number there. We're then going to say the fact itself, the row that we've selected, is going to become equal to cursor.fetch1, We've only really got one in there, but this is just how you do this with SQLite. And then we can close the connection because we don't need to open the database any longer. We can then return the fact, or the 0th fact from the variable. It should actually only have one in there. If fact else, no fact found. So in the very bizarre situation where we get a number that's not between 1 and 100, we should never actually hit that else clause there. So we should return the fact that we're interested in. Now the next function here, initialize database, this is essentially going to create the database and fill it full of information. Actually, this is just going to create it from scratch. So initialize the database, we create the connection using SQLite connect to our facts.db. We can then say create table if not exist, facts, and the columns of our table are going to be an ID column, that's going to be an integer, it's going to be a whole number. It's also going to be the primary key of our table. And we're going to have another column which is called fact, and that's going to be a text column. And that can't be empty, so not null means that that column has to have information in it. And that's it. We then commit that. That means write it to the database and then close the database. So that's initialize now database. Next up is loading facts into the database. So this is where we're going to take those raw facts from that markdown file, and then for each one that's in there, read a line in, and then create a new column in a new row in our database. So the first thing we do is initialize our database, that one we just created above. We're going to create a new connection to SQLite facts database. We're going to create a new cursor, and then we're going to execute delete from facts. So it's going to delete any information that's in there already. There shouldn't be anything in there because we've just created it from scratch. But that's just making sure everything is as we expect. Next up we say we have this try except clause. This means that if there's an error in running this code, it will just jump to this error message here. So with open raw facts.md, so this is our text file, we can then say lines equals file.readLine. So it's going to read in all the lines into an array of lines. And then for each line in lines, and we're going to basically skip over the header rows, that's what that 2 colon there means. And it's going to split the lines up wherever there's a pipe symbol so that we get the information in the way we expect. So we should have a number and a fact, number and a fact. And if we're going to split the line, if it equals 4, then we're going to basically split out the line into the actual fact. So the first 4 characters are essentially just the number. So there's like a space, number, and then space. The fact is going to be equal to split line to strip. So it's going to strip off any white space at the end or the beginning of the fact, and it's basically just going to split that into 2 parts there. So it's going to take the split line which we've just taken there and take the second half of it, which is the fact information. And then it's going to say cursor execute, insert into facts the fact that we've just taken from our text file, and we're going to pass in the actual fact as the value that we're going to create in there. And that's it. That's going to create all the facts that we want in our database. If there's that raw facts doesn't exist, it's going to print out a message there, and otherwise it's just a general exception. It's just going to say an error occurred and pass in whatever that exception is to help us debug that. We're going to commit that, we're going to write that to our database at that point, and then we're going to close that database file. So next up we have load facts into database. At that point actually just executes that function that we've just got there. Really that should probably be further down, but we've got it there just because that's where I put it when I built it. Now the next thing is this @ symbol and this line above a function. This is called a decorator, and this is a decorator that's built into FastAPI. So this .get means that FastAPI will create a .get or a get API. So there's at least 4 different types of API that you can make. Normally when you have a web browser, you're just making GET requests. You're saying to the web server, get me that page at this address, and the web server will just fetch that page and provide it to you over HTTP, Hypertext Transfer Protocol. There are posts as well. Post is where you want to provide information to a web server. So if you filled out a form, for example, or if you pushed a button to submit something, that will post it to the web server. The web server can then receive that information and do something with it. And you've also got update, which is a bit like a database. If you want to provide an update or a delete, there's those as well. So there's at least those. We're going to have a look at the different types of message that you can, the requests that you can make. using another tool called Postman in a second. So this is going to create an API, get API that's called --random-fact, /random-fact. And here's the function. It's an async function, which means asynchronous IO means things can happen at any point. So we don't know when it will happen, but when it does happen, this is the code that will run. It will simply return the fact, and it will get a random fact. So it's going to return essentially like a JSON object. It's essentially a list in dictionary, in Python. So we have these curly braces to define that it's a dictionary, and we have key value pairs. So that's the key fact, and then the actual fact itself is get random fact, which calls the database, pulls that random fact, and puts it in here. So this will then return that back, and it essentially looks like a piece of JSON code via the API. And then this last piece, if name equals main, this means if we run this code straight from our browser, this is what it needs to do. Otherwise, we can run it using UVcorn, which is what we've done before. So we import UVcorn. This is a FastAPI server software. We then basically say loading facts. We load the facts into the database, and then we run the code. So let me show you the next piece of the puzzle here. So what I'm going to do, I'm now going to load up the DB browser. So this is our DB browser, that the free piece of software that I showed you the link to earlier. And we can see on here, we've already opened up the random facts, facts.db. And we can see the database structure. We've got tables, we've got indices, which are indexes to make the access to certain columns faster. We've got views. Views are a saved query in effect. And we have triggers, which is if you want to have something happen, so say a row is created or a certain value is created in a row, you can have some action, some stored procedure run there. So we have a table. We've just got one table. It's the facts table. And you can see on there that if I open that little disclosure window, triangle, you can see we've got ID and we've got fact, which is integers and text. And it's an ID is an integer and the fact is not null. Now if we go over to browse data, we can actually see the facts table. It's the only table that we have there. And it looks a bit weird the way it's spaced out on here. I don't know why it's done that. I think it's something to do perhaps with Unicode or something, where each I don't know. It looks weird. It might be that the characters are stored as, the spaces are stored as tabs or something weird like that, but it's done the same with the ID. It doesn't actually matter. It works fine. But this is internally how these work. You can see there we've got 100 records. Each one is a separate fact. And if we wanted to, we can execute some SQL in here. So if we wanted to say select, star, you should never really do star, but star from facts, and we then run that, we get a list of all 100 rows. So we could create some SQL if we wanted to, but it's easier just to browse the data. You can even do things in here like create new records, and so on. So it's very, very nice and simple to use. So that's the DB browser. And the other thing I wanted to show you is something called Postman. So Postman is some other free software, and you can use this if you're poking APIs, as they say, if you're creating APIs and you want to work with them. And these are the different types of requests that we can make. We can do get, post, put, patch, delete, head, and options. So get and post are the common ones. So if we go over to this one here, this https://facts.kedgerobots.com/random-fact. If we send a request to that, a get request, you can see there we've got a fact sent back. So the fact is the Da Vinci surgical system. I think I met the person who developed this actually when I was on holiday. Assists in complex surgeries with precision. We can send another request and get another fact. A name, Yumi conducts orchestras and is performed with Andrea Bocelli. Interesting. Now if we did a post request to that, that wouldn't work. It would basically just say that that method isn't allowed. We don't have anything to respond to that. But if we go back to the get, we'll get the fact that we're interested in. And it's returning it as a JSON object. You can see there it says JSON. We can also view this as the raw. Pretty just basically puts it on different lines. Raw displays it as it appears to us. You can preview it in Times New Roman if you really wanted to, if it was HTML, and so on. So you can see that that's the body, that's the actual response that comes back there. So Postman is a really nice piece of software for working with APIs. Okay, so the next thing I was going to show you is the really cool thing about, yes, let's go back over to here, to the fax one. So I can do the same thing in a regular browser, just keep returning regular fax. It doesn't look pretty just because it hasn't got any HTML around it, it's just the raw JSON. Robotic dolphins are used to develop ethical alternatives to captive animals in aquariums. Random. So yes, what I was going to say on here is we can actually, if we go back here and we type in docs, we get the documentation automatically created by FastAPI. This is a really cool feature of FastAPI. So if we click on that, we can get all the information about this. So we can see there it's expecting strings and so on. We can even try it out. So if we click try out, we can execute a request. So it looks like it's doing a curl. That's a piece of Unix software for getting information from web servers. We can see the URL that we've requested. We can see the response back from the server is 200. That means everything was good, okay. And the response body is fact. In 2021, a robot called Simon 2, equipped with AI, was sent to the ISIS space laboratory to interact with astronauts. There we go. And there's all the other header information that we got back from there as well. So this is a really cool feature of FastAPI. It's self-documenting. So the more API routes that you create, it will actually give you ways of testing those out and documenting it as well. This used to be called Swagger, but it's now just called FastAPI, the OpenAPI JSON. There we go. So I love the fact that this is all built into FastAPI. Cool. So that's the rest of the things I wanted to show you. I'm going to show you the Markdown itself as well. So I'll go back over to, if I go to my kevsrobots.com, this is where I create all the content for Kevs Robots, and it's all Markdown. So if I show you a course I'm currently writing about, let's see, about Pydantic, which is it works with FastAPI, sorry, to do data validation. So if I just define this course, and let me show you the actual contents of that, because it's all zoomed in, it's a bit easier, a bit difficult to see there. So if I go to Pydantic, so for example, this is what the Markdown looks like. So we have these triple slashes to say everything between these two triple slashes is called front matter, and it's essentially YAML data. And we can have things like a title, description, a layout for the page, which is like a template, the type of content that this is a page, and I have another one called cover, and that's like the cover image that we're going to display on there. So it looks very similar, other than a few of the little strange things like this in Markdown. It reads pretty much like plain text, and these double pound signs, do you call them, or hash if you're in the UK, they've got a very strange name, haven't they, those? Octothorpe, I think it is. Octothorpes. They essentially mean that it's a heading style. So 2 is heading style 2 in HTML. We've then got a list. So you can see these dashes mean that there's a list. Double stars between anything between two pairs, a pair of double stars means that that's bold, and we have triple slashes for our horizontal line. So this is really cool for creating content very quickly and having something like Jekyll automatically build your website from that. So this is what I use to create the content of the pages. Now the random fact one, let's actually go and find the random fact one. I'm actually going to find the jQuery for this and the actual components that we created. So in here there is a section that's called includes, and these are kind of like little components I've created for the web page. So I'm just going to find the one which is for random facts. I probably called it something like random fact. There it is, random fact. And this is the content. Let me just hide that so we can look at this. So these div tags basically just mean like there's a wrapper, and we're going to put some content in there. So this wrapper is a container style. This is all part of Bootstrap. A heading 5 style, random robot fact, and then we've got this ID, which is a way of uniquely identifying this tag. So this is called random-fact, and then it starts off by just saying loading fact. And we've got some jQuery, which as you can see here, this between these script tags. This is actually JavaScript that's going to grab the fact for us. So it's going to go to facts.kezrobots.com random fact. You can see there's the development server commented out there. And if the response is not okay, then we basically just say there's an error. Otherwise, we return the response. So the response will be the fact itself, but in JSON format. Then we're going to basically get the element by ID, random fact. So in our HTML, where we've got that ID is a random fact, we're going to replace the content of that with this data.fact. So it's going to replace the content of that loading fact with the actual fact itself. Otherwise, if there's an error, any other errors, there's a catch-all that just says log to the console, and you can see that if you're in Chrome or Safari or any browser by going to the console, the developer tools, and seeing what's in there, and it's basically just going to say that it failed to load the fact. Then it's going to do fetch random fact, which is that function we just created there, and then that's the end of the script. So that's pretty easy to use. So I'm going to see if there's anything else we need to call out there. Well, that's pretty straightforward. So if we now go to kezrobots.com, let's go to kezrobots.com, and we scroll down, see this little area just here. Just hide that advert. Random robot fact: the world's first autonomous robot kitten assistant called Sally can make custom salads. Kitchen assistant. Did I say kitten? Kitchen assistant. If we refresh the page, we will get another random fact. And sometimes, if it doesn't quite catch it fast enough, you'll see it saying loading fact, and then it gets overwritten as it's sort of waiting for the response. The first robot marathon 42-kilometer race was held in Japan in 2011. So there you go. So it's picking up all this styling from the container and all the other information that we put into that HTML in that little component, that little include file that I showed you earlier. So all of the background ochre, rounded corners, rounded corners 1 style. I think you can do 1, 2, or 3. Margin top 3, and padding is 3. So that all that coding there essentially gives you this information. So it's really cool because you can add changeable information to a statically generated web page using APIs. So that was the very first one. That's a very simple one because we're essentially just grabbing information from an API. We're not sending anything back. So let me see if there's anything else we need to talk about on there. No, I think that's pretty much it. So you can check out that yourself by just going to facts.kezrobots.com / I think there's random-fact. There we go, random fact. And we can pretty print the results when they come through. Pepper, a humanoid robot, can read human emotions and is used in customer service. How random. Okay, so that is random facts. So the next one I built was a bit more complicated than the random facts one. I think I actually built this one first. This one is a search facility. So one of the main things I thought was missing from KezRobot, there's all that content in there, but there's no way to easily search it. Now you could use something like Google search and embed a Google search button within there, but then you also get all the extra cruft that comes along with that, all the adverts and so on. I wanted something that was just very pure, and it's also a bit of an exercise in, could I build a search engine? How hard would that be? It's a lot simpler than I thought. So this is going to be a two-way API. So unlike the random facts, which just use get, this will also have the post. We can send the thing we want to search to our web server. It can then take that, query the database, and provide us our results back. So it's going to take that search string of text, whatever that might be, and then it's going to see if it can find any results for that. Now we also want to rank the results in order of relevance, so we need to pick some kind of page rank algorithm of our own making. So is it going to be the most recent, whenever the page was published? Is it going to be how many hits it gets for a particular keyword that you provided in the search string? So we need to come up with some kind of ranking system for that. And it returns the results in JSON, just like we did with the random facts, and then we can make that pretty using some formatting in our standard generated and some jQuery as well to format the results. So this is how we're going to do this. So we're going to scan the source code of all our web pages. This is the built pages. I'm just going to add that to my list of things to show you in a second. So that's the sites area. Once it's scanned everything, and we have, because I've created this website myself, I've got access to the raw rendered HTML pages. We can extract information from those pages. We can extract tags like the URL of the page, the title of the page, a description of the page, images like the cover image, and the actual text content itself. But we only want the text content. We don't need all the formatting that we get with HTML. We can basically just point the user to the page. We're going to load all that information into our database. So similar to what we did with those raw facts, we're going to do that kind of similar process, load it into a database, and then we're going to write a Python program with FastAPI to make all that happen and run that in a Docker container, just like we did with the random facts. I'm still going to use Cloudflare as my router protection, and also it can speed up some of the results too. I'm going to add some jQuery as well to KEDRobots to grab the, in this case it's going to be the search, not the random fact. And you can try this out yourself if you go to search.kedrobots.com/search query equals, and then speech marks, and whatever you put in between the speech marks is what it will search for. If you go to there, that's the raw results in JSON format. We can have a look at that in a second as well. So how do we actually scrape the content out of these generated web pages? And why didn't I do that from the raw markdown files? So we need to build a database that has searchable content. We need to do this by crawling through the pages themselves and pulling out all the key data. Now the reason I didn't just use the raw markdown files is that the markdown files might only be a section of the page. They might not have header information, breadcrumbs, all that kind of extra stuff in there. And that actually adds to the thing that we want to search for. So sometimes the markdown files might be just really limited, and really we want to provide the full URL for the pages to be able to point the user to the right location. So it's actually better to search the generated web pages themselves rather than the raw source markdown files. And we're going to have the title, the description, the URL of the file itself, a cover image. Now I actually embed within every single web page using some little tags, using an include function in my Jekyll system that will have an OG image. This is for, I think originally Twitter, but also other social medias use these. So if you provide a link to a page and post that into a social media, if you have these OG tags, these meta properties like the title and the description, they can build a little card, a little preview card. It looks different on each social media platform, but you actually have to do that. That doesn't come free. You have to provide those little OG tags and so on. So the cover image, we're essentially going to pull out the location of the image rather than the actual image itself. The publish date, so if I've given a date to each of these files, and I think I do for everything that I create, and an author as well. They are all part of these meta tags in the meta block. We can actually look at some of the raw HTML content as well for that in a minute too. So let me just add that to a list of stuff I want to show you. So like I said, they don't come for free. We have to bake those into the markdown, and then they get baked in with into the HTML when Jekyll produces those. Now the library that exists for creating all these extractions is called Beautiful Soup. It's a really nice piece of Python, very simple to use, and it essentially can extract text or tags from a page, and it's how you do web page scraping. So if you just wanted like a table of data from say Wikipedia and you didn't want to have all the other stuff that's in there, you can use Beautiful Soup just to target the tables and then extract the data from them. And the content, we actually want to pull out the content as well, and there's a really cool feature in SQLite that's called Full Text Search, or FTS5 version 5. And that's a way of storing the information, the content, the text content, and making it really searchable very quickly, and also providing some kind of rank for how often keywords appear in there. So it's pretty cool. So let's have a take a look at this one next. So what I'm going to do, I'm going to go over to here again. So we're back. I'm going to go back over to Kev's Robots. Let's go to the other window. There we go. And let's just go to. I'm just going to show you a bit easy what's going on here. So when Jekyll, when you're working with Jekyll, you'll have all your source files, which are here. And when it's generated the actual content and built the site itself, it creates a _sites folder, and this is essentially what you publish on your web server. So if we go over to, for example, the robots, you can see there's like an index.html, and that's the fully generated page. The actual robots index, if we go to the source on here, so if we go to robots and the index.md markdown, that's all there is. So there's not very much in there. So there's a layout, which is the type of page that template we want to use. The title is robots. The subtitle is learn different about robots. A thanks section is the sort of yellow section that says thank you for your interest in this page. I've set that to false because I don't want it in there. There's a description, which is essentially the same as the subtitle. I think I now use description over subtitle. That was an earlier redundant use. Then an excerpt is part of Jekyll. You can have a bit of an excerpt of the page. And then we just have this include. This is how we use those includes, robots.html in our page, and it'll basically just replace that with the actual content of whatever's in robots.html. So if we go back to that robots page, you can see this is what it looks like as a fully generated page. So I'm just going to open this up a bit full screen so we can see what's going on. So if you've not seen HTML before, this is actually how web pages are built up. So the document type is HTML, the language is English, and then you have this head section. So this is where you have all the sort of metadata. So we can see in there we've got viewport sizes, we've got a title of the page which is called robots. We've got links to the style sheet, that's the cascading style sheets that gives the page its sort of theme. We've got the type of document, this is a text and JavaScript document, and we're also going to bring in this termly. So this is a little block that brings in all my privacy policies and terms and conditions. They're actually generated and hosted by a company called Termly. I have to pay for that. Then we have a block which is some more style sheets. So this, I use Font Awesome for some little glyphs and things on the site. Whenever you see like a little calendar icon or a thumbs up, they come from Font Awesome. And we also have some other links to Bootstrap. We're on 5.3 there. And the final one is Typekit, which is like a typography, brings in some extra types there. And we're also bringing in some Ajax, some jQuery. And I think highlight.js is a little function that if you have source code in a code tag, it will actually detect what type of language it is and make it coloured, so you can see the keywords in different colours. So that's what that does there. And then this is the bit I want to show you. So the meta properties, OG description, depending on which social media you're using, these are generated from the description tag in the markdown. You can see there we've got that again. For Twitter, it has this card, the URL, description and title, and the site as well. There's that cross-origin thing. We saw that course that we needed to add before. That's what that's to do with. I've also got some code for bringing in Mermaid. Mermaid is like a really cool, you can provide text description of a diagram and it will build the diagram, and it's all in JavaScript. It's all done on the client side. Cool. So those meta tags are the things that we built in from our front matter and that we can actually scan using Beautiful Soup. So I just wanted to show you that kind of how that's built in the background there and how it goes through that. So now we're going to have a look at the actual folder where our search app lives. So if I just scroll up here, search app, there it is. And we've got a number of different files in there. So that _pycache_ is where Python, the full version of Python, stores its already compiled program. So Python will take your code, it will interpret it, it will build bytecode, a bit like Java does, and it stores the cache of that, so it doesn't have to keep generating code that it's already generated in that little Py cache there. So that's what that does. It just gives it .pyc thing. You can't actually look at that, it's just sort of machine code. We've got a folder that's called search. So we've got a underscore, as they call it, double underscore, init, double underscore. You always have those. There's nothing in there, but you have to have them if you want this to be like a library. And then we've got a function that's called a file that's called database.py. So database.py stores all the code related to database functions and kind of abstracts that away. Sometimes they call this like a database abstraction layer. So we're bringing in SQLite 3. We are creating a variable that's called search database. Now the convention with Python is if you want to have a constant, so something that doesn't change within your code, you put it all caps. So search database isn't going to change in our code, and then we're just passing that in there. So similar to our raw facts one, we've got an initialized database, so it's going to grab a database connection, it's going to create a virtual table if it doesn't exist, document FTS full text search using full text search 5, and we're going to pass in all the different columns that we need, title, content, URL, and so on. Just move that there so you can see the rest of the page. It's going to commit that and close it, so that just creates us a nice fresh database. We can get the database connection, which is what we used up there. And that's because we do it so many times, it's just easier to create a function that does the same thing, that just returns a connection. And that connects to our search database. Insert document, so this is when we want to create our database and build it out. So there's some kind of error handling in here, and essentially we can pass in all the different things like the title, the content, the URL, all the things we want to store in there. If the author is none, then just set it to be me. If there's no date, set it to be whatever the date was when I created this, so 30th of December 2023. If the description is none, then just say no description. We can then get the connection, we can execute insert into our document full text search, all those different columns, commit it and close it. Now this total results is just a little function that gives us how many results do we actually have. And it's quite useful when you're given a query to know how many results are going to be returned, because we can use that for pagination, for pagination. If we want to say, rather than returning everything on one single page, if there's like 10,000 results, it actually makes sense to paginate them and say only return 20 results at a time. So this helps us work out that pagination using total results. It essentially just counts how many results are returned. So select count from the whatever the results are. We then execute that, return the total count. And then the query documents, so we pass in the query, that might be like the word Python, for example. This offset and limit is to do with pagination again. So the offset is how many pages in do you want to display from the results, and the limit is how many results do you want to return for this particular page. So you can tweak these. You could even have this exposed if you wanted on the web page, but I've not done that yet. So if the offset is none, then set it to 0 at page 1. If there's no limit, then set it to 10. So 10 results will be returned per page. So we're going to get the connection. We're going to print out to the terminal just so we can see what's going on, what the query is, what the offset and the limit is. And then here's some SQL. So select distinct URL. So only return where the URL is unique, because we don't want the same results. If the word Python appeared on 20 pages or 20 times in the same page, don't give us 20 results back, just give us the one result. So that's what distinct URL means. Return the cover image URL, the page title, and so on, and where the document full text search matches that question mark, and that's what we pass in as the query itself. We then group them by the URL, we order by rank, and then we limit, we pass in a limit as well. A little bug on my desk there. It really distracted me, that. So then we execute that query, and then we return the results, and we return it in a dictionary. This is actually a list with a dictionary inside, so the URL is the URL, the cover is the cover, and so on. And we just return that as results. And if we run this without any parameters, we essentially just create a new database. We just initialize it. So that's our database library. So let's jump back to search. And let's have a look what else we've got in here. So we can actually jump out for a second and have a look at the database itself. So if we open the database, let's go for our search. So this is Kev's Robots, and then search app, and then search.database. And let's just wait that for a second to display some data for us. There's a lot of data in there, so it's going to take it a second to just pass through that. Okay. So, yeah, that's probably the one to go for. Let's go for the structure for a second. So you can see we've got 6 tables, and these are all generated by this full text search. So we can see the columns that we're interested in, so the title, the content, URL, cover image, page title, and so on. And then there's some other things like the actual content itself. It's got some other things in here as well for indexing. We don't need to worry about those, they just kind of make the full text search thing work well for us. But yeah, you can see in there we've got lots of different entries. You can see the URLs from them as well. And that's all in the background, so I think there's an awful lot of information in there. So that's, if we wanted to use that to browse through. Okay, so let's have a look at the main site and front matter. Right, so we've had a look at an example page there. So title, description, layout, cover, and type. So they will get baked into the actual generated page itself. If there isn't an author or there isn't other information in there, we get those default values that we put into our database program. Let's see what else we've got to look at in here. So let's go over to the main search app itself. So if we go over here, app.py, this is the main program that runs our API. So let's have a look at this. So we're going to bring in FastAPI requests and requests that we don't actually use. I don't know why that's in there. Date time is just for if we're working with dates, because each page potentially has a date in it. This is useful for doing date calculations. We're importing login just to log out any errors. That's a standard kind of Python methodology. We've got that cross-site origin thing as well, just to prevent any errors with that. And we've got the database library that we created. That's how we bring it in, search.database. So that's the name of the folder, and that's the name of the Python file itself. And we're importing insert document, query documents, and total results. We're also bringing in this typing. This is like a Python typing thing. Types are like the type of variable you're using, like is it an integer, a string, and so on. And we can just bring in that it's optional. And we're also bringing in time, because we might want to work with some time functions as well. This is because we want to actually time how long it takes for the query to run, because that's quite a useful thing to bring back. It's something that Google does as well, so that's what that's for. So just like the facts one, we're going to create an object that's called app from FastAPI. I'm going to set up our basic logger as well, so this is how we log things out. I'm using this because I actually want to know what people are searching for, because that might give us some ideas for things I should build in the site if they don't exist. So we're going to create a file that's called search-logs.log, and because we're using the logger, we'll get like the date stamp and any information that we pass to that. So we're going to set up that cross-site origin thing there. That makes everything work. We've then got the first of our routes. So this one is the post route. So this is where we send information to the web server and we want it to do something. So this is when we receive that from the /documents, we want to essentially create documents. So we can give a title, a content, a URL. We can then insert that title, content, and URL, and we can just return that the document was created successfully. So that's how we can actually upload extra documents if we wanted to. And we've then got the main search API there. So again, search documents, there's going to be a request. This is the HTTP request, sorry. The query itself, the page, which is optional, and these are the pagination. So what page do you want to actually view? Is it page 1, page 2 of the results? and how many results do you want to return back. So this maps to our limits, so the page size, how many results per page. Start time, we basically just say put the current time into start time, and that's the timer running, so we can see how long this actual request takes. The client IP is the request client. It's always going to be my router, I think, this one, or the Pi that it's running on, so it's a bit defunct, that one, to be honest. And the current time, we just grab that in the ISO format, and then we log that out, so log entry equals the current time, the IP, and the actual query, and that's where we login.info creates that log entry in the log file. So then we do the actual results. We grab the results, so we say results equals query documents, the query, the offset page -1 times the page size, and then the limit equals the page size, and then we then say the execution time, how long did that take to run that query. So that query documents is the thing that does the querying of our database. Then the total count is how many results do we get for that particular query, so total results query, and then we can just print out the total number of results that came back. And then we can return these results, so return the results that we have, and also the page count, the total number of results that there were, and then how many results per page, the page that we're currently on, the page size, and the execution time. So it just gives us something that we can then use to display some extra information on our search page, on our search results page. This is then, this was a search, but I think I've got rid of that and use this one above here, so this probably doesn't actually do anything now, so we can probably just ignore that. That code never gets used. So that's actually our app. It's as simple as that. It's not many lines of codes to make. There you go. So it's probably around, go to that one there, about 50-ish lines of code to create your own search engine. It's pretty straightforward. So let's have a look at some of the other things we've got in here. So we've looked through the search folder and the database. We looked at the main app.py. So I've got this build app, deploy app, and rebuild.shell script. So this shell script is my way of just flattening the database, just deleting the old one, and then recreating it. So we actually just remove search.db to remove it, and we can then run the database program. Remember when I said if you just run it, it'll create a blank database, and then we can then say time Python 3 index.py. So index.py, let's have a look at this one. This is the code that will go through each of the pages and pull out all the information. So this is kind of our scraper. So let's have a look at this. So we're bringing in OS, the operating system. We're bringing in Beautiful Soup. So BS4 is the name of the library, and Beautiful Soup is the function that we can use to interrogate web pages. We're bringing in our search database, and we're going to insert documents into our database. So that's what that function is there. Parse HTML files. This is the thing that's going to do the scraping. So this is the real workhorse. So open the file, whichever file we're currently working on, in read-only, and in UTF-8, which is like the standard encoding for web pages on Unix and Windows, as file, and then soup is going to be our Beautiful Soup library. So we're going to bring that in as LXML. And then the title is going to be soup.title.string. So this is going to take that file, and it's going to find the tag that's called title. Otherwise, if soup title doesn't exist, just say no title. The content is going to be soup.getText. We're going to have a look at what that does, but essentially that's going to take out all the text from the web page and remove any formatting from that. So it'll just be the pure raw text. We're going to get the URL, so that's the file path. Just replace web/sites with nothing, and also get rid of any other leading folders on there. We're going to find the cover image, so OG tag image equals soup.find the meta tag with the property OG image. We're going to find the cover image. We're going to set the cover image to be the OG tag content. And essentially that will just give us that the path to the URL for that image. The description tag, we're going to find the meta property description. We're going to again just pull out from that tag the content of that tag, if the content and the content it actually has that attribute. Otherwise, just set it to no description. And what's that? So that's just to read the comment there from Dale. And essentially we're going through all the tags that we're interested in, finding them using beautiful soup within our page, and then just pulling out just that information and storing that in a variable. So each of these variables then has the information that we need. We can then correct the cover image URL if we need to, so we just need to provide the base URL, which is the website kevsrobots.com. If there is a starts with HTTP, then we just want to replace it with HTTPS. If the cover image starts with HTTP, replace it again with so this is just some error checking just to make sure that we get the nice URL however it's formatted. And if we have .com// just replace that with .com. Sometimes we have this double slash thing appearing. That's just a way of getting rid of that. I did set this H1 tag. I don't know why we set that in there. I think it's to probably find the title, but we didn't need to do that. We can just find the title from the title tag at the very top. And then we insert all that information into our database using that insert document that we looked at earlier. And then the main function simply just walks through that underscore site, the generated contents of the site, each directory that's in there, each file that if it ends with .html, and then parse it. So then just look to see if there's any information, put it out into our database. So that's the main indexer program. That's the thing that does most of the workhorse there. Let me see if there's anything else we need to look at there. So we looked at that. Right, so let's go back over to Postman. And let's go to this first window here. So this is going to do a GET request on search.kevsrobots.com, search, and then actually it should be a post, I think, that one. And we're going to search for the word Python. So let's send that off. Oh, it was actually a GET, sorry. Let's send that off. And if we just make this a bit bigger over here, you can see the results we get back. So we should get 10 results. So there's one block there, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see that the total count, the total number of results is 564, and therefore there's 57 pages. We're on page 1 and the page size is 10, and it took 0.056 seconds to execute that query. So that's what it looks like if we directly hit that. We can go to our browser. I'll just grab that exact same thing. Go to our browser. Let's type in that same result there. And this is what it looks like. It doesn't look great there, but there is now this pretty print option, so you can actually see what the results actually look like. So that's been sent to our web page. So let's have a look at kevsrobots.com kind of for real, and let's type in Python. So we hit that. These are the results that we get. You can see there's 564 results, took 0.29 seconds. It's just loading up the image for each of those. They're not particularly optimized, these images, that's why they take a little bit longer to load. And we can see there that the Learn Python is the URL. It's got the title and the description. It's got when it was published. You can see there, these are the different results. And we've got this pagination at the bottom as well, so we do that. You can see there it says and page 2 as a parameter. Got that Rust one that we covered a couple of weeks ago, page 3. And they've got the getting started with Python and SQL. We click on the URL, it takes us straight to the page as you would expect. There we go. And that search bar is on the top of every page, so we can search for ROS, for example. Let's have a look at that. Now you can see there, Learn ROS with me. So it's pretty good at guessing the correct link. The reason it's pretty good is because of that full text search, and that will return the rank is how many times that word ROS appears in a particular page, and therefore pushes to the top ones that have more instances of that. So the word ROS will appear quite a number of times on this page. In fact, if we do a search for ROS, it appears 37 times on this page. If we go to the next best result, let's have a look at what is ROS, for example. Let's search for ROS. That appears 30 times. So you can see there the number of times a word appears is our crude ranking system. So it works pretty well. So what's happening in the background here, if we actually look at let's inspect it. Let's have a look and see what's going on. So if you press that inspect function on Chrome, you'll get this developer tools window, and you'll see here we've got the contents of the page itself. So if we let's make it about there, and let's just find the search bar and see what we can see. So where is it? I think it is in there. Now, one way to do this is to click on this little arrow here and then just click on the component you're looking for. So there we go, and that will take us straight to it. So we've got this little group. It's actually a form. We can have a look at the source code in a second, but this is how it's generated. So the input class form control, it's a search box, it's a type of search, and the placeholder text, the text that sort of sits in the text before you type in the placeholder, is what you're looking for. And if we just click the next bit, that's the actual button that will submit it. So within our page there is actually some, if you can find it to be one of these scripts that's in here, and this script will be the code that queries the back end. So rather than looking through it this way, let's go back and look at the code. So if we go back to our includes, we can find that there's a search component that I've created. So let's find that search bar. So this is the code. It's quite straightforward. That sits behind, when you press that submit button, it will find the element that's called search box. It will log out to the log search query, and it will post that off to the location that we've specified in there, which is the search results query. So that's what it will then load up next. So you can see that there is actually a page that's called search query. Let's go to that. So if I go to, so that's not an include, that's actually just a raw page in the root of the site. Let's just go there. So search results. This is what that looks like from a markdown perspective. So it's a layout. The template we use is called content. The title is called search results, and we're including the breadcrumbs because we want every page to have that. And then we have the search results, find results, blah blah blah. And then we've got an ID. This is what gets overwritten by that JavaScript query, search query display. And we've then got that function to create the pagination as well. So that's a bit of JavaScript to work out how many pages and therefore display the correct number of links to that. And you can see there that it's going to create a new component that's a link for each of them. It's going to paste in the results, and it's going to append that to that. So I think it's a list, which is a type of component. So you can see there we've got this UL, which is an unsorted list, and we're basically just appending each thing to them unsorted lists. And the page next and page forward is just how many page buttons do we have, and that basically just changes that little parameter in there. And then we've got that listener, which basically just listens for that button being pressed on there. And this is the bit that does the actual work of the sending of the results, sending the query off to the thing and then grabbing the results back. So displaying the results is the bit that actually overwrites each bit. You can see there the actual HTML. So we've got rows, we've got some columns in there. The columns are to split the image from the text. And then you can see, so we've got the image URL, we've got the page title, the page description, formatted date, the results URL as a link, and then the actual results URL as the text for that link. And that's it. And then we have at the bottom just the page navigation. So let's go back to the page itself. If we scroll down after we've got some results, let's just type in again Python in there. So you could see there for a second it had like nothing in there as it was actually operating the results. And if we scroll down to the very bottom, does it say on there, or did I not provide that information? Oh yeah, we have how many, so we searched for, that's the actual query, that's the number of results, and that's how long it took to return those. So yeah, works pretty well. I'm quite pleased with how that sort of turned out as a function, and it's just a bunch of Python running on some Raspberry Pis in the background, and it's very simple to update. So let's see if there's anything else. No, that's so the last thing I wanted to show you, yes, was the actual search log. So let's see what people have been searching for. I always find this quite interesting to have a look at. So if I go out to, let me find the Pi that's got this in it, it's this one here. So if I just minimize all the other consoles, so there's 4 Raspberry Pis that we're running, so I usually have all 4 open. Let's just minimize that. Right, so let's just clear the screen and let's type in cat to catalog to sort of print to the screen, search logs.log. We should see a whole bunch of Python. They're the ones I've just been doing, but let's look, people have been looking for the word battery, CV0, blueprint, Pico, UART Pico, ROS2 and a Raspberry Pi, cat papercraft, Slam, Samba, Olama. So quite a lot of interesting things. So what I've not built yet is something that can analyze those logs and kind of show me the most common things, but that should be quite trivial to do. But that's what that standard Python logging function does. We logged out the date time, the IP address, which is the actual IP address of the machine itself, and then the query that people have searched for. So pretty cool. That's how we can build a search engine in Python for statically generated pages. So if you want to get yourself some merch, we've got a number of different hats and things. There's my Robot Maker hat, we've got the red version there. I should definitely have to order myself some other colours of that. And some mugs. I need a mug for work actually, so I'm going to get myself another Kev's Robot mug. I think I've got 2 of them there. Go to kevsrobots.com/merch for that. And if you've not joined our Discord, you can head over to kevsrobots.com/discord and you can get a sign up link there, completely free. And we've got a really growing community of people all helping each other with robot stuff. If you want to follow me on social media, I do post a lot of stuff, particularly this robot arm that I'm currently working on, which is an absolute monster. That's one section of it. There's the other section. So this is still a work in progress. Might have to do some changes to this, but head over to KevsMac at threads.net for threads, at KevMacLear6 for TikTok, at KevMacLear for Instagram, at KevsMac at X, at KevsMac at Mastodon Social for Mastodon, and at KevsMac.bsky.social for Blue Sky. And you'll get some behind the scenes stuff on there throughout the week. And if you want to help support the show, there's a number of different ways you can do this. You can do a super thanks if you're watching this on replay. If you're watching this live, you can do a super chat. I'm going to switch on all the stream elements for that now. And you can also join the YouTube membership program by clicking the join button once you've subscribed to the channel as well. And you'll get your name in the end credits. You can also go to kevsrobots.com/coffee for information about how to buy me a physical coffee, if that's your preferred thing to do instead. Okay, so let's give a shout out to the people who have supported the show so far. So a couple of people bought me coffees in the last month. So we've got was that Simple CY, we've got Mark Lewis, and then we've got a number of members who've joined the Buy Me a Coffee membership. So we've got Lee, we've got Alvaro, we've got Mary Louise Mayer, Jeff Johnson, Dian Corte, we've got Marlene Brent, Tom, Shemi, and Steve Phillips. Hey to people who are watching that live right now. And then on the YouTube membership side, we've got Johnny, we've got Hybrid Robotics, Dale, we've got Bill Hoy, Warren Steele, Steve Cross, Jonathan R, Orksrad39, Vince, John Paul Jolly, Alistair Ware, Cassie, Tinkering Rocks, JDM, Johnny Bates, Hans from Cheerlights, Michael, and of course we have Tom as well. So if you want to get your name in the credits, you can go to kevsrobots.com/coffee or kevsrobots.com/credits. I think it's pretty much the same thing there. Cool. So yes, that's everything I've got for you today. So let me just go back to here. So if you're watching this on replay, you'll probably get a recommendation for another video just around here. Please click on that and watch another video. It really does help. It's as good as subscribing if you choose not to do that. And they're both free. So thank you so much for watching, and I shall see you next time.